That's actually a good story, because I guess I must have been around 10 years old, and I was wondering what the print circuit boards were made from. And I know that they're not made from composites, they're made from epoxy only. But then I figured out that, well, that is the same that goes into a lot of the things that I was surrounded by, because I came from the countryside in Denmark, and we had silos, and I put one and one together and figured out, well, that is the materials that's used in composites, this really tough and rigid plastic that doesn't rust. So that's where I discovered it and figured out this is a special material.
I have a PhD in nanotechnology, and actually I come from a background in biological composites. So my introduction to composites actually comes from a completely different world, namely biology. And in biology you see so many different cool materials, and many of them are true composites. My main focus was on bone, where you see remarkable assembly of different kind of properties, and they really relate to the composite nature of this and the structure on at least 7 different hierarchical levels. Quite remarkable. My core interest has always been material properties, and whether they come from the biological world or from the engineering world, it's of course 2 different approaches, but the material properties are similar, and what we can achieve by mixing different kind of materials, which is the case for composites, the principles are very similar. I really believe we can learn a lot from the biological system on how to build good materials.
In Vestas, our blades, those big pieces sitting in front of the wind turbine catching the wind, they're made of composites. They're made of epoxy composites, glass fiber reinforced epoxies. What you don't see is also that a large fraction of modern blades are also made of carbon fiber reinforced composites. So we use it due to the strength of it, the durability, the light weight of it as well. So here it has that many advantages to us. So with the blades that are this light, we can reduce the mass of the rotor, reduce the loads of the wind turbines, and make much more efficient wind turbines, much more efficient fashion, capture the wind and produce electricity to you and I.
Sustainability is obviously quite close to my heart, and I think with all the focus that are now on making these materials even more sustainable is really good. But actually just understanding that the nature of composites in itself is quite sustainable. The best thing you can do is to make products that last for a long time and that you want to use for a long time. It's been a hard nut to crack. I think we have made a big step since we recently discovered that we are able to recycle blades even in a circular fashion. And that is not only new blades that we are producing today, but also going back in time. This is a new innovation. We did it with some very good academic partners, Aarhus University, Danish Technological Institute, but also with one of our big suppliers, Allan Epoxy. We are starting up a pilot project, really bringing that technology from the lab and into the industry. So this is something we are very proud of and something we're really looking forward to display much more over the coming years. I think composites is a very versatile material. I think you can tweak it to a quite large degree. So to start to understand that range of possibilities that will give you as a new company, that would be my obvious first step. And I think many would be surprised of what composites can offer them, because it is a really versatile material with a lot of nice properties.